These students, so three cases in route stability construction. So we're going to do problems on three cases. So I have explained you last two cases. The first one is normal route array, okay, non-zero element in the first column of route array. What is the first case? Normal route array. So we have examined it only in the first column of the elements, whether the positive or negative, and we have checked it. So if all the first column elements are positive, so we said it is a stable system. So if there are sign changes, what we said, number of sign changes is equal to number of routes located on the right above the S-plane. The two sign changes, the two routes are located on the right of the S-plane. On the second case, so a row of all zeros. So we have done two problems. So on this case, a row of all zeros. Okay, so when you doing route array problem, so there you come across a complete row become zero. It means complete row become all zeros. So what is the procedure? So if you just continue like that, so route stability criterion will fail, so you can't get the answer. So what we did last time, so we have taken auxiliary equation. So after auxiliary equation we have differentiated and continued the procedure, and we commented on stability. Okay, and the third case is first element of a row is 0, but some or other elements are not 0. Okay, first element of row 0, but not all. Okay, so you seen that in the second case here, second case was seen like this. Second case, so like this, suppose s square, s power 5, s power 4, so s power 3, like this. So what happened here, you got all 0 rows in the second case, but in third case it's not like that. It's just the first element of row become 0, and the other elements may not become 0. It may be 2 or whatever it may be. Okay, so it's not only s cubed, so any s square also the first element may become 0, right, like that. Okay, so this is the third case. Today we are going to do problem on a third case. We are going to do problem on third case. Okay, the third case the problem is construct route array and determine the stability of the system represented by the characteristic equation. So this is the characteristic is given to us. Okay, so we have to determine the route stability criterion, and also we have to comment on location of the roots of the characteristic equation. So how many roots are there right of this plane, how many roots are there right of the S plane. So we have to comment on this, and also we should tell whether the system is stable or not. Okay, so we just formulate the route stability criterion. So we see that the given equation, what is the given equation? So the given equation is s power 5, the given equation is s power 5 and s power 4, okay, 2s cubed 2s square plus 3s plus 5 is equal to 0. So this is the given characteristic equation. Now we have to form route array. Okay, so what is that? S power 5, s power 4, s power 3, s square, s power 1, s power 0, s power 0. Okay, you see here, what is the power? The power is 5. So therefore we have 5 roots in this characteristic equation. There are 5 roots in this characteristic. So we have to determine how they are locating these 5 roots, how they are going to locate. Okay, we have to determine. Okay, so you know that now what is the odd powers of S? Okay, odd powers of coefficients. So you see that here 1 here 1, and this odd power 2s cubed. S cubed coefficient is 2. Okay, and S power S coefficient is 3. So these are odd powers, S power 5, S power 3, 3s. So these are odd powers. Next, even powers coefficients we have to write here. So here 1 into S power 4. So 1, next you get 2, next is the 4. Okay, next is the 5. So we have to formulate route array for this. Okay, how to formulate? So we need to find S power 3. S power 3, we have to find it. How to find S power 3? So here 1 into 2, 1 into, so this is a 1 into 2, and so upside is the plus and downside is the negative. So what is that? 1 into 2 minus 1 into 2 divided by 1. This one divided by 1 is equal to 2 minus 2 by 1 is equal to 0. So you got 0. So next 1 into 3. 1 into 3, then again 1 into 5. 1 into 5. So what is that? 1 into 3 minus 1 into 5 by 1. So you get 3 minus 5 by 1 is equal to minus 2. Right. So this value become 0. This value become 0 and this value become 1. Okay. So further you will get 0. So now if we just continue so what happened? So it will be a problem. So what we have to do? This 0 replaced by small positive, that is called epsilon. You replace 0 by small positive. Okay, this 0 should be replaced by a small positive, this one. Okay, so I'm going to write here. So replace 0 by epsilon value. This is a epsilon is a small positive number. It is approaches to 0. It is approaches to 0. So I'm going to consider this one as a epsilon. For time being, I'm going to consider as an epsilon. Then I will continue with this. Now we have to find, so S square coefficient. So what is it? 2 into epsilon. Okay, minus 1 into 1 by, what is it? You have to divide by epsilon. So what is the value you will get? You will get here 2 epsilon. Okay, so 2 epsilon. This is a minus. This is a minus 2. This is a minus 2. This is a minus 2. So 2 into epsilon. This is the minus. So here the minus is there. This become plus. So this become plus. So 2 epsilon plus 2 by epsilon you will get. Okay, 2 epsilon you will get. Okay, so here this value is here 2 epsilon plus 2 by 2. 2 by 2. So further you do it. So epsilon into 5 here. Epsilon here is 0 is there. So next epsilon into 5 minus 1 into 0 by epsilon. Okay, what do you get? 5 epsilon by epsilon. So epsilon gets cancelled. You get the 5. So this value become 5. Again you have to continue. You have to find S1 coefficient. If you find S1 coefficient, so you will get, you just cross multiply minus 2 into, so I am taking another sheet here and I'm going to write here. So minus 2 into, so I'm going to write it here. So you're going to take S as a minus 2 epsilon, S1 coefficient, 2 epsilon plus 2 by 2 into minus 2, so minus, okay, 5 into epsilon by, you have to divide by this, 2 epsilon plus 2 by 2. So after dividing, so you will get this value minus 5 epsilon square. You take this LCM and do it, you will get 5 epsilon square and 4 epsilon plus 4 by 2 epsilon plus 2. So this value you will get here. So I'm going to put star here in this place. I'm going to write here. So what is this value here? So this value, this is the star value. Okay, if you further you do it, it will become 0. Then what is the S power coefficient? S power coefficient is, you just multiply, so this into this, so you finally you will get, so you will get only 5. You will get only 5. Dear students, there is a small correction. I have pronounced epsilon as lambda. So make a correction. So this is not a lambda, this is a epsilon. Thank you. 5. So now what you do, so you now substitute lambda is equal to 0. Okay, when substitute lambda is equal to 0, so what you get? So lambda here in S cubed, in S cubed row there is a lambda is there. So this, when it is approaches 0, so you will get 0. So now it is, this lambda is 0. Now S square. So S square, what is there? Limit lambda tends to 0, 2 epsilon plus 2 by 2. So when you substitute here, what happened? 2 by 2 into 0 plus 2 by 2. So what you get? You will get, so this you will get 2 by 2. So you will get 1. Okay. So this value become 1. So when you S cubed, okay, S cubed. So S cubed I will do it here. S cubed. So where is your S cubed? Sorry, S1. So your S1. So your S1 limit lambda tends to 0 minus 5 epsilon square, 4 epsilon plus 4 by 2 epsilon plus 2. In substitute 0, so what do you get? So minus, so 5 0 square, okay, plus 4 into 0 by 4. So what happened here? 2 epsilon means 0 plus 2. So you will get here, so 4 by 2, that is a 2. So this value is a 2. Okay. So this value is what? This value is, we have find it here. That value is, so we got it as a 1. That value we got it as a 1. So I'm going to write in a first sheet, and a first sheet I'm going to write here. So here I'm going to write, so what do you got? So S power 5, S power 4, 3, S square, 1 and 0. So what is the got 1, 2, 3, 1, 2, 5. After here was the epsilon was there. See, you see that here is the epsilon. When you substitute 0, so it become 0, 0 minus 2. So what happened here? Here 2 epsilon 2 by 2. to epsilon 2 by 2. So when you substitute here we substituted limit epsilon tends to 0 to epsilon by 2, so you got this value is a 1. So you got this value is a 1. Okay, now this become 1, this become 1. So after that, so as usual, so after 1 this one is the 5. So now what happened, this star means here, what is a star? Star means here this one, star means here, star means this one, minus 5 minus of 5 epsilon square plus 4 epsilon plus 4 by 2 epsilon plus 2. So when it tends to 0, when epsilon tends to 0, you got a 1. So in this place I am going to put 1. Okay, in this place I am going to put 1. Alright, so finally you will get epsilon is equal to 0 if you just put it. So we are in a small correction here. So you just see that 2 epsilon by 2, so this should be epsilon, this should be epsilon. So therefore what happened, this value become, so when you put epsilon, this value become infinity, this value become infinity. So here should be infinity, here should be infinity, here should be infinity. So next one is, what is the next one? Minus of 5 lambda square plus 4e plus 4 by 2 zeta, so sorry 2 epsilon plus 2. So we have seen it here, this one. When you substitute here, epsilon is equal to 0. So what value you will get? You will get, so minus 2. So here after substituting here, so you will get, here minus is there. So I forgot to put here is the minus. Okay, so you will get minus 2. so this value become, so minus 2, so that value become 0. So this will become plus 5. So I will repeat again. So you got a coefficient here, the value was 0 here, value 0. So here what we got, s square. So x coefficient was, so that is 2 lambda, okay, plus 2 by lambda. So limit lambda tends to 0. So when you substitute here, just s square I am talking about it. So what happened when you substitute 0? So what happened? This 2 by epsilon means 0. 2 by 0 is infinity. So again, what is this one? S1 coefficient. The S1 coefficient was like this. So minus 5 epsilon square plus 4 epsilon plus 4 by, so 2 epsilon plus 2. Okay, so this is epsilon tends to 0. So when epsilon tends to 0, what happened? 5 into 0 square plus 4 into 0, okay, plus 4 by 2 into 0 plus 2. So you will get minus 4 by 2. So what you get? Minus 2. So that's a minus 2 I have substituted. Here what happened? S cube, there is a epsilon. So when you limit, when you substitute epsilon is equal to 0, so you will get, so this value you will get 0. Okay, 0. So now this is the first column. We examine the first column. Okay, so examine the first column. So this is the first column. So when you examine the first column, so we have to find the how many sign changes. You see that here is the plus. Okay, this is a plus and minus. Okay, again minus and plus. There are two sign changes. You just see here. So this is the plus, this is the minus. This is again plus. Okay, So we see that this is the plus 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 plus, then plus to minus, one sign changes, and minus to plus, that two sign changes. How many number of sign changes in the first column of route? So two sign changes. Two sign changes means two poles are locating in the right half of the S plane. I have told you number of sign changes is equal to number of poles lie in the right half of the S plane. So I write here number of sign changes is equal to number of poles lie on the right half of S plane. Okay, so this is a very important, okay. So what is the so I'm going to make a result here. I'm going to write a result for this problem. So the result is since there are two sign changes, so this all first count the elements are not positive, so that the system is unstable. The first one is the system is unstable. This is unstable system. So what is the second point? So second point, we have to comment how many poles are lying. So what is the question we asked? Comment on location of the roots of characteristic equation. So how many roots are lying? Okay. So there are two sign changes. So two poles are lying on the right half of the S plane. So I'm going to write here two roots are lying on the right half of the S plane, and three roots are lying on the left half of the S plane. So what is the final comment? System is unstable. Since two sign changes are there, so what happened? Two roots are lying on the right half of the S plane. Rest of the three roots are lying left half of the S plane. So this is the conclusion. Okay, this is the conclusion. This is the result. So next problem is determine the range of K for stability of unity feedback system whose open loop transfer function is G of S is equal to K by S into S plus 1 S plus 2. So this type of problems are very important. So SBTE in the final exam definitely they will ask one question on this. Okay, so you have to find the range of K for stability, okay, for this unity feedback system. Okay, so when we solve this problem, so here, so first to understand the question, and write what is the given data. So you just see that what we have to do first here. We have to determine the range of K for stability. So what value of K a system would become stable, and also here is given unity feedback. Okay, so this is the unity feedback means here H of S is equal to unity feedback. So unity feedback means H of S. So H of S is equal to 1. Unity feedback means H of S is equal to 1. So what is the open loop transfer function? So your open loop transfer function, that is G of S is equal to, so already they given K by so S into S plus 1 into S plus 2. Okay, so you know what is the transfer function? Closed loop transfer function. So closed loop transfer function, you know that the closed loop transfer function, so that is C of s by R of s. C of s by R of s is equal to what you will get? So G of s by 1 plus G of s into H of s. H of s. Okay. So what is H of s here? H of s is equal to 1. So finally what you get? So here you will get, so C of s by R of s is equal to, so G of s by 1 plus G of s, 1 plus G of s. So you have to substitute what is G of s. What is G of s? So what is G of s? So G of s is equal to what? K by okay, s into s plus 1, s plus 2 by 1 plus G of s means K by, so s into s plus 1, s plus 2. So when you take LCM and all, so what you get? You get C of s. So C of s by R of s is equal to, so you will get K by 1 K by s into s plus 1, okay, into s plus 2 plus K. So we know that this is a characteristic equation. So by using characteristic equation, we have to formulate Routh array and find the stability of the system. This is very most important. So now I am going to take a characteristic equation. So what is our characteristic equation here? The characteristic equation is, so what is the characteristic equation? You see here, s into s plus 1, okay, so s plus 2 plus k is equal to 0. This is the characteristic equation. So I want to form Routh array formulation. So what I do, just I am going to multiply inside. So when you multiply inside, what happen? S into s square, okay, plus 2s plus s plus 2, okay, 2 plus k is equal to 0. So s square, 2s plus s, 3s plus 2 plus k is equal to 0. So when you multiply inside s, what happen? S cube plus 3s square plus 2s plus k is equal to 0. So s cube plus 3s square, 2s plus k is equal to 0. Now we have to construct the Routh array formulation. Okay. So how to construct the Routh array formulation? You know very well how to construct. So that is, so what is the, so here, yeah, 1 2 3, okay, s cubed is there. So you have to write s cube, s square, s power 1 and 0. So you may have 3 roots since it is a s power 3. So what is the odd powers of odd powers coefficient? Here 1, s cubed coefficient is 1 and s coefficient is 2. Then even powers coefficient is, then s square coefficient is 3 and this one is the 1. So what are the s1 coefficients? You just multiply this, okay, multiply this. So 3 into 2 minus 1 into k by, you get a 3. So what is that? 6 minus k by 3. So this value 6 minus k by 3. So further it become 0. Okay. Now s power 0 coefficient we have to find it. What is that? 6 minus k 3 into k, okay, minus 3 into 0 by 6 minus k by 3. So what you get? You get k value. So this becomes 0. 6 minus k by 3 by 6 minus 3 by 3 into k. This both is cancel. You get only k value. So this is, I have constructed Routh array. So you see that this one is the first column. This one is the first column. So this is the first column. Okay, by substituting k value, so we have to find the stability of the system. This is one the column 1. See, now we can determine the stability at this moment. So what we had, if we know the k values, so you are able to determine whether the system is stable or not. Okay, so what I'm going to do here, so so you have, so yes, you see that, so systems to be stable, what I'm going to do, k greater than equal to 0. So from s power 0, okay, from s power 0 row, okay, for the system to be stable, so k greater than 0. Okay, then from s power 1 row, for the system to be stable, 6 minus k by 3 greater than 0. Okay, you see that here, if you put k value negative, what happened? The system become unstable. Okay, if you put k value negative, so what when this system become unstable. So I'm just considering k greater than 0. Okay, so for the stable system, for here also 6 minus k by 3. Okay, so we do here, so 6 minus 3k, 6 minus 3 k by 3 greater than 0, it means, so 6 minus k, so when you cross multiply, you will get 0. Okay, it means here this means, what this means, the value of k should be less than 6. So here it means the value of k should be less than 6. Okay, the k value should be less than 6 or greater than 0. Okay, so now what happened, if we just this is 6 minus k is there, 6 minus k, so if we just send this side, what happened, k less than 0, so k value should be less than 6. Okay, so less than 6, so what happened, you just understand here. So why I'm taking it, suppose you take k is equal to 1, if you substitute here k is equal to 1, so what happened, so s power 0 row, s power 0 is equal to, this is the k, this is the s power 0 is equal to, s power 0 coefficient is a k, so we substitute k is equal to, so this will become, so 1, we substitute k is equal to 1. So s power 1 coefficient, what is 6 minus k by 3, if we substitute k is equal to 1, what happened, so 6 minus 1, it means 5 by 3, it means this is a 5 by 3, it means you will get positive value. Okay, so once if k is equal to 1, this is a positive, value, so the system is a stable. If we substitute k is equal to 2, so we will get the positive value. If we substitute k is equal to 3, you get the positive value. If we substitute k is equal to 4, you get the positive value. If we just get the k is equal to 5, so what happened is, when substitute k is equal to 5, what happened here, 5, so 6 minus 5 by 3, it means 1 by 3 is a positive value. When you substitute k, 6 is equal to 0 or above, what happened, you will get 0 or a negative value, so therefore the system become unstable. So system to be stable, what happened, k value should be less than 6. So the range is this, right. So k value should be greater than 1, less than 6. Between this the k value between this 0 and 6 should be there. Okay, k value should be greater than 0 and less than 6, then your system become stable. So the range of k, so I am writing here the range of k, for the system to be stable is the range is, so this is the range. Okay, so I am going to write here the result I am going to write. So what is the